differentiation, sometimes y refuses to be solved alone. Like, you get an equation something like x squared plus y squared equals 25, and in this, the y is not the subject. On the other hand, this kind of equations that y is the subject, we're used to solving these kinds. But what to do when you see y and an x together, or in which the y is not the subject of the formula? We call this an implicit y, because in this, the y is hidden, implicit. So to solve this, we use a thing called implicit differentiation. Implicit differentiation just follows one simple rule. Whenever you see a y, you differentiate that y and then multiply dy over dx. First, let's apply it to the simple questions that we always see, which is the second one. So you just see a y, the differentiation of a variable is just 1. So you just say 1, and then you add dy over dx, as I told before, and then you solve the rest regularly. So you just say x squared becomes 2x, and 3x becomes just 3. Similarly, you can do the same thing over here. Remember, the rules still stay the same. You just differentiate regularly, but when you see y, you differentiate y and then multiply dy over dx, just like in this one, like 2x plus 2y. Now dy over dx equals 25. Now the question is not done yet, because you're finding the differentiation, or in other words, you're just trying to find this dy over dx. So you gotta make this the subject of the formula. How do you do that? You make dy over dx the subject. And it's gonna be something like 2y dy over dx stays the same, 2x goes on the other side, it's gonna be 25 minus 2x. And then you divide both the sides by 2y. And something like dy over dx would be 25 minus 2x divided by 2y. Pretty simple. Sometimes the question could be like giving you examples which are like using some product rule, quotient rule. You don't have to panic. You just, whenever you see an x, you do what you do before. Like x squared becomes 2x. But when you see a y, you do the same as before. Like y squared becomes 2y, but multiply dy over dx. Remember, don't forget that. That's the crucial rule of implicit differentiation. Then, let's just do this example. Sin x becomes cos x. And similarly, sin y becomes cos y, but again, dy over dx is being multiplied. Let's do a different example in which there's a product rule. You can see x and y, so instead of just rushing in, you just denote like your x to be u and your v to be y. And then you can just find the u dash, it's gonna be 1. And then you can find the v dash, it's gonna be 1 again. So then the formula says, and again, look, when you differentiate the y, you gotta add dy over dx. So now, when you're done with this, you just simply differentiate the formula by using u dash v plus u v dash. Now replace the things that I taught you. 1 multiplied by y plus x multiplied by dy over dx equals the differentiation of a constant is 0. And now what? Now you make the formula the subject of the formula. It's gonna be y plus x dy over dx equals 0. So you take y on the other side, it's gonna be x dy over dx equals minus y, and then you just divide x on both the sides. And then finally, you're left with dy over dx being minus y over x. Pretty simple. Again, you can have question in any form in which there could be more than one y. So instead of making it subject, you just follow the same rule. You differentiate regularly as you do, but then when you see a y, you just differentiate it and multiply dy over dx with it. If you follow the simple step, implicit differentiation becomes easy, because in the end, then you just have to factor dy over dx alone and make it the subject. Pretty simple. Let's do one last example and see how it goes. So if you're given like a question, x squared plus xy plus y squared. So first of all, x squared is pretty simple. You can just simply say x squared becomes 2x, and let's look at this xy later, plus something, and then this thing, y squared becomes 2y, and don't forget to multiply dy over dx. Now, for this xy, we have done this xy here, and we got y plus x dy over dx. So I'm just gonna copy the answer from the top, and it's gonna be y plus x dy over dx. And this is equals to, the differentiation of 7 is pretty much 0 because it's a constant. Then you just do 2x plus y plus x dy over dx plus 2y dy over dx. Now, what you do is first group the dy over dx together. So it would be x plus 2y. So it's going to be x plus 2y. And this whole thing is being multiplied with dy over dx. And take the others on the other side. It's going to be minus 2x minus y. And once you're done with this, you just divide the whole thing by x plus 2y. And when you do this, this thing gets cancelled and dy dx is my subject of the formula, and then it's going to be minus 2x minus y, x plus 2y. Pretty simple. If you went for simplification, it's going to be one of the hardest questions you can solve in calculus. So that's why instead of using that, we use implicit differentiation. And when people solve this, the one common mistake they just do is they forget putting dy over dx when differentiating with y. So again, I'll put a reminder that when you see y, you differentiate it regularly and then put dy over dx. That's why the method on the left is incorrect while the right is correct, because the left one is missing dy over dx. And if you follow just this simple rule, you can do these questions easily without any problem. And if you want to give it a shot, you could just try this one, x squared plus 3xy plus y squared equals 20. You can do this one and comment your answer, and I'll pin the correct answer. And if you have any other further questions for me, leave it in the comment section and I'll get to you guys. Alright then, have a good one.